Here's the start of our third video for section 7.3. So we have our values here, but these are for our exponential inverse. We can graph that if we want to. I'm not going to, but we could. Instead, we're going to swap our x's and our y's because that's what we do with inverses. We want to get back to this one. This is the exponential form of our original function. So to swap our x's and our y's, I'm just going to change our columns. So I'm going to go to 1/9, -2. I'm going to go to 1/3, -1. I'm going to go to 1, 0. I'm going to go to 3, 1. And I would go to 9, 2. It's off my graph. But it's going to look something kind of like this. And just like with our exponentials, when we had an asymptote on our x-axis here, now we're going to have one on our y-axis because they're inverses. Our x's and our y's swap. So that's what our graph's going to look like. Now we're going to come up with some information here. We need our domain and range, x-intercept, and asymptote. So our domain is the range of our exponential function. Okay, our domain is the range of our exponential function. And we could only have positive numbers in our range before. If we look at our graph here, we're only going to have positive numbers that can be our x's. Okay, we can only go this way for x's. So our domain is going to be all real numbers greater than 0, not equal to 0. Remember, with our exponential function, we had that asymptote at x equals 0. Same idea here, it's just swapped. So instead of being x equals 0, it's y equals 0. Our range is the domain of our exponential function, which is all real numbers. We can have every y value here. Remember, range deals with y's. We have an arrow going down. This arrow looks like it's going right, but it's actually going up and right. So it's going to keep going on forever and ever. And our asymptote, that line that it's never ever going to cross, is now y equals 0. Remember, we swapped our x's, swapped our y's. There's no values that we can plug in for x's that are negatives or x equals 0. If you try and do that, you're always going to get undefined answers with our logarithms. What is the graph here? Describe the domain, range. I didn't say my y-intercept on the last slides explicitly, but we don't have one. It never crosses that y-axis, and the asymptote. So, a couple things we know right away. We know that this function right here, a logarithmic function, is not going to cross our y-intercept unless there's a transformation. Here there's not. So there's no y-intercept. We know our asymptote is going to be at y equals 0. For logarithmic functions, those are always true. Our range is going to be all real numbers. And our domain for logarithmics are all real numbers greater than 0. Again, unless there's some kind of a transformation, which we don't have here, that's what it's going to be. Now, in order to find our graph here, we need to switch it to exponential form. We can't just graph from our logarithmic form. So we have 4 to the y power equals x. We don't know what y values we'd get if we plug numbers in for x. So instead, we're going to find the inverse here, which takes us to our original exponential function. We get 4 to the x power equals y. And this is the inverse exponential. And finally, something we can plug numbers into. We can finally plug numbers in for x. We couldn't up here. We don't know how to solve that. We couldn't here. We don't know how to solve that. Here we finally can. -2, -1, 0, 1, and 2. When I plug in numbers, 4 to the -2nd power, 1 over 4 squared, again, negative exponent, we move to the denominator to make positive. And I get 1 over 16. 4 to the -1st power, same thing. 1 over 4 to the positive 1st power, which is just 1/4. Anything to the 0 power is always just 1. 4 to the 1st power gives me 4. 4 to the 2nd power gives me 16. And again, this graph isn't super great for that. I should have put a different one on, but this is the one that I have, so I'm going to go with it. That's for my inverse exponential function. I don't want that. I want my original logarithmic. Means I need to take the inverse. So I'm going to take and swap my x's and my y's. Now I'm going to have y's where I had x's and x's where I have y's. So my points are going to be 1 over 16, -2, 1/4, -1, 1, 0, 4, 1, and 16, 2. 1/16 down -2, 1/4 down 1, 1, 0, 4, 1, and again, 16, 2 is going to be somewhere over there. So connect them. Make sure we don't cross that line. Arrows on both ends. Our domain, all real numbers greater than 0, we can plug in any x value there. That looks good. Our range, it looks like we have arrows going positive and negative. That looks good. We don't have a y-intercept, so that's perfect. And we drew in an asymptote. These get closer and closer to 0, but don't actually get to 0. So we're never going to have a y value equal to 0. So what we have on our graph matches what we should have on our graph. Take note on page 455 is our families of logarithmic functions. So parent function, y equals log base b of x. As long as b is greater than 0, b is not equal to 1. Again, our a value is a stretch or a compression. If our h is inside with our x, it's horizontal. If it's added afterwards, that k value, that's a vertical transformation. And so same ideas as we've been doing with absolute value, with quadratics, with polynomials, with we used them with radicals, we did exponentials, now logarithmic functions. So when we look at this, a value is just 1. We don't have anything else, so there's no stretch or compression. This right here, that 3 goes left, sorry, that's right, 3. Our 4 goes up 4. So we're going to start off with our parent function, y equals log base 4 of x. We're going to go 3 to the right, and we're going to go up 4. That would also change our domain, our range, and, it wouldn't change our range, but it would change our asymptote. Our asymptote would switch over 3 as well, so now it would be at y equals 3, and our domain changes as well. Our domain would be all real numbers greater than 3 when we move to the right. Okay, just like with our range of our exponential functions, since they're inverses, the same things happen to our domain in logarithmic functions. Give A a try. Okay, our parent function is y equals log base 2 of x. We're going to go 3 to the right. We're going to go 4 up. Our asymptote's going to change here because whenever we have a Horizontal change, it changes our asymptote. And it works the same kind of way. So instead of being at y equals 0, we move it to 3. So y equals 3 is our new asymptote. Same thing with our domain. Instead of being all real numbers greater than 0, it goes to 3. All real numbers greater than 3. Okay, part B here, there should be a 5 there. That's my bad. That 5 is going to be a stretch because it's our a value. Our parent function is still going to be y equals log base 2 of x. And nothing else changes, guys. When all we have is a stretch or compression, it didn't move left to right, it didn't move up or down, our domain doesn't change, our asymptote doesn't change, our range doesn't change, nothing else changes the same. Everything stays the same. So a real quick recap on this section. I know it was kind of a long one. The exponential function y equals b to the x is 1 to 1. So its inverse, x equals b to the y power, is a function. To express y as a function of x for the inverse, we have to use logarithmic form here. Okay, these two are inverses. An exponential function is a function with the general form y equals a to the bx power. As long as a is not 0 and b is greater than 0, b also can't be 1. In an exponential function, the base b is a constant. X is our independent variable, and the domain is a set of all real numbers. So, in exponential form, our general form, our domain is all real numbers, x is our independent variable. Logarithms are exponents. So, log base b of a equals c only if c is the exponent to b and it equals a. So if our b's are both our bases of a equals a and c is the exponent. That's the only way these two are equivalent. I'm going to flip to the assignment. You can go ahead and start on it if you want to, but we will have time to work on this in class tomorrow. So that is the end of 7.3. Thanks.